Okay, class, welcome back. So yesterday we were talking about arc length, we were talking about linear speed. We didn't quite get to an example. So today I'm going to quickly go through an example, and then I'm going to give us a review of the entire chapter. So I'm going to go through everything, every little piece really quickly, from converting radians to degrees, to arc length, coterminal, angles in standard position, etc., etc. Okay? So let's do an example. We're going to start off by finding linear speed. Finding linear speed. So here's our example. So we've all seen the huge windmills that are used to generate electricity. They've been popping up all over the place. Okay, those things have massive blades. And so the question is, how fast is the very tip of that blade going, based off of just sort of how fast sort of the windmill is turning, right? So here I've got, I'm going to quickly draw out my little windmill. Mine isn't going to be a super high-tech windmill, but it's going to be a more old school windmill. Okay, so say my old school windmill, I know that one blade from the very center all the way out to the tip, just like that, is going to be 10 feet long, or 10 feet distance, right? And so if I'm standing there, say this is like a Don Quixote type of windmill. If you guys don't know Don Quixote, you should. So Don Quixote was a Spaniard who fought with windmills. Anyway, so this thing is sitting here spinning along. And I'm trying to figure out, okay, if I was like a squirrel or something, or a little bug, and I wanted to go for a fun ride, and I wanted to just hang out on one of these, the ends of one of these windmill blades, and I could just hang there, how fast would I be going? Okay, so the trick is, initially, I'm sitting there watching this thing, and it's spinning pretty fast. And so I notice that every second, if I just look at this one blade, every second, I've got my stopwatch out, it's going 4 revolutions every second. So it's going 1/1000, it's going even faster than I'm doing right there, all right? So I can say that my angular velocity, or my rotation speed, is omega, and remember this is going to be equal to theta divided by time. So in this case, omega I count is 4 revolutions per second. 4 rev per second. Well, the first thing I need to do is, I can't really do much with revolutions per second, but I can do a ton with radians. So I need to take this omega, this 4 revolutions per second, and convert it into radians. So I say omega is going to be equal to 4 revolutions per second. And I'm going to multiply that because I know one full time around here, one full time around for my windmill, of course, is 360 degrees, or class, how much is one full time around in radians? That's right, it's going to be 2 pi. So I'm trying to get my units to cancel, so I know I need to put 1 revolution here. 1 revolution around is going to be 2 pi radians. So my units here cancel, and I just end up with 4 times 2 is going to be 8 pi rad per second. Now I've got my omega in 8 pi rad per second, or just 8 pi per second. Now I can really easily find out what my velocity of my little bug or my little squirrel is hanging out on the edge of this windmill blade. So I can say my velocity from the equation that we learned yesterday is going to be equal to r times w, which is going to be equal to 10 feet. My radius is 10 feet, right? Times omega, in this case it's going to be 8 pi rad per second. And once again, if I have radians and I'm being multiplied by another unit, the rads just kind of go away. It's a cool property of radians. So if I do this, I just find out, sure enough, my little bug or my little squirrel is going 80 pi feet per second. Or really quickly, this is going to be about, you can plug it into your calculator, figure out what 80 times pi is. This is going to be about 251 feet per second. Pretty darn fast. Okay? So if you're a little bug or a little squirrel, you better hang on for dear life. Okay, so now draw a line there. We're going to review. and I'm going to review this stuff really, really quickly. So far, we're at about 5 minutes into the video. I'm going to try to get all of the review done before 10 minutes. So when you come to class tomorrow, be prepared to just work through lots and lots of problems, and make sure you're writing questions in the margins over here so that we can get those answered in class. Okay, so the first things first. We're talking about angles, right? So we've got initial sides, terminal sides, vertices. Okay, so degrees. First, main thing you need to know what degree measures is there's 360 of them in a rotation, or one revolution. 360 degrees in a revolution. Boom. Now we need radians. We just answered it up above, but same thing. We've got 2 pi radians in a revolution, which means one trip around a circle, you end up with 360 degrees or 2 pi radians. Now, of course, we need to be able to convert back and forth between these two. And if you guys can either memorize it, you can determine it yourself. Basically, if I have radians, I'm trying to convert one from the other, back and forth, etc., etc., then I can do that really quickly if I know. So say, if I know what that conversion is. So say I've got 60 degrees, okay, and I'm trying to convert it to radians. So all I need to do is take 60 degrees, multiply it by pi radians over 180 degrees. This is our magic number, pi and 180. Which one goes on top, which one goes on bottom? It depends on what you're trying to cancel out. In this case, I've got degrees up top, degrees at bottom. They cancel out. I end up with 60 over 180 times pi, or 60 pi divided by 180 rad, which is just going to be pi over 3 radians. Nothing to it. Now let's go in the opposite direction. Say I had pi over 4 radians. Now, same thing, I need to try to figure out, okay, how am I going to do this? So I've got pi over 4 radians. I need to multiply by something, same thing, this pi 180 relationship, but I need the radians on the bottom. So this time I need to end up with degrees. I'm going to put that on top, and I'm just going to put pi radians on the bottom. So my rads cancel, and I just end up with 180 pi degrees divided by, and then I've got a 4 on the bottom and a pi here, 4 pi on bottom here. Pi's cancel. 180 divided by 4 is just going to be equal to 45 degrees. Converting from one to the other. Okay, let's jump to drawing angles in standard position. You can go back and check out these videos if you want, if you're still a little bit confused, but going through it really, really quickly. Once again, if I'm drawing things in standard position, the tricky part is understanding where I'm starting, and I'm always starting right there. Always on this x-axis right there, that's where I'm going to start. If I'm going in this direction, it's going to be positive. If I'm going in this direction, it's going to be negative. Now also be careful. Okay, I've got some definite landmarks here. So here we've got 90 degrees, here we've got 180 degrees, 270, and 0 degrees up here at top, and 360 on bottom. Sorry, that's a little bit on the small side, but hopefully this is a review. You guys should be able to knock this out real quick. And of course, if we were to draw the same thing in radians, once again, I want you guys thinking about radians, not just in degrees. So here we've got 0 radians, here we've got pi over 2, pi, this is going to be 3 pi over 2, and this is going to be 2 pi radians. So the equivalent sort of diagram just drawn in radians, okay? So if you're comfortable, right, if I give you an answer in radians and you're comfortable in radians, by all means, solve it in radians. If you're not quite comfortable yet, then convert it to degrees, figure out what your answer is, and then convert it back to radians, okay? So say I gave you, let's see, say I gave you this problem right here. So I wanted to either draw, or I wanted to, say I said draw negative 3 pi divided by 4 in standard position. I'll just put SP, standard position. Quick example. Okay, so there's a couple different methods to do this. If you want to, you can convert this to degrees. So I say negative 3 pi divided by 4 times, once again, I need to do the conversion, 180 divided by pi, multiplied. Okay, so the pi's cancel. I get 3 times 180 divided by, or sorry, negative 3 times 180 divided by 4. And sure enough, this is going to be equal to, let me think here, got to do some quick math in my head. This is going to be equal to negative 135 degrees. Now if I'm going to draw this in standard position, okay, so once again, always starting off on this positive x-axis, if I'm going negative 135, I know I'm at least going this far in the negative direction. Once again, clockwise is going to be negative, so I'm going 90 degrees there. And if I subtract 90 from 135, sure enough, I find out I'm at the 45 degree mark. So if I go right there, good to go. That's going to be 140, that's going to be 135 degrees, and even to mark it, I can put 45 degrees right here. But of course, this is also, this angle right here is also going to be 45 degrees. So this right here is what my angle looks like. Negative 3 pi over 4. It's going to be minus 135 degrees. Okay, now let's jump right to coterminal angles. Coterminal angles. Remember, coterminal angles, they're the same angles. The relationships are going to be a little bit different. But basically, you're starting at one point and you're ending up facing the same direction. It's just a matter of how many times you're spinning or in what particular direction you're spinning. Okay? So say, example, say I said, okay, give me, I want 395 degrees in terms of coterminal angle. So I want it somewhere in the range of 0, I'll put an X. I want your answer between 0 and 360 degrees. Okay, so 395 clearly more than 360. So I need to take 395, subtract 360, and all it's going to give me is 35 degrees. Done. Find the coterminal angle. Got it figured out. Okay, another example. Say I had negative 765 degrees, and I want it, same thing, between 0 and 360. So the first thing I need to do is negative 765 degrees. I'm going to start adding 360 degrees, right? Start adding revolutions here. And so if I add 360 degrees to 765, what I'm going to get is negative 405 degrees. Okay, so I'm still not in this ballpark, so I've got to try it again. So I'm going to say negative 405 degrees plus 360. Still trying to get into this 0 to 360 range, right? So if I do the same thing, sure enough, I'm not quite done yet. I've got negative 45 degrees. So I've gone 2 full laps in the positive direction, still at negative 45. Okay, so negative 45, now I'm getting closer. Negative 45 degrees. I can right away see that all I need to do is just add one more on top of that. And sure enough, negative 45 plus 360 is 315 degrees. Done. So that's going to be my full complete answer. So that's going to be my coterminal answer to negative 765 degrees. Okay, couple more examples here. 3 more examples and then we're done. The first one is, say I'm looking for the arc length. Example, find arc length if, say my radius is going to be equal to 8 feet and my theta is going to be equal to 225 degrees. Well, this shouldn't be too hard because I remember right away that my equation is going to be, S is going to be equal to R times theta. However, oops, I'm way off the screen here. S is going to be equal to R times theta. However, remember theta, I've got to put this in radians in order for this to work. So the first thing I need to do is convert theta into radians. So I can say theta is going to be equal to 225 degrees times, once again doing my conversion, pi over 180 degrees rad. And I can figure out that this is going to be equal to, I've got 5 pi divided by 4 rad. Now, I've got this there, so I can just say S is going to be equal to R, which is 8. 8 times 5 pi over 4, which is going to be equal to 8. This just is going to be equal to 10 pi feet. Remember, so my radius is 8 feet, so my answer needs to be in in feet as well. So 10 pi feet, but because we're talking about feet, I don't want the units, I don't want it 10 pi feet. You could just quickly punch this in your calculator and say, okay, this is going to be 31.42 feet. Excellent. 2 more examples and we're finished. Actually, you know what? Let me go ahead and draw a line there. That's enough review for the day. I want to keep your videos short. I realize I'm at the 15-minute mark, so we'll pick up from here tomorrow. If you guys have questions, particularly on the applied stuff, be sure to bring them to class. Look forward to seeing you guys tomorrow.